So welcome friends, in this video we are going to learn about spatial interpolation. So let's begin. Spatial interpolation is the procedure to predict the value of attribute at an observed point within a study region using existing observation. So in the simple language we can say that spatial interpolation is a process of interpolating a unknown point between known point. So spatial interpolation consists of these methods, these 6 number of methods, and in this video we are going to learn about these 6 methods. So in simple language we can say that spatial interpolation is used to create a surface area in 3D or to predict the unknown point. So at first we will begin from the Hessian polygon. So let's start. Hessian polygon. Hessian polygon is an exact method of interpolation that assumes the unknown value of the point on a surface to be equal to the value of nearest known point. This can be considered as a local interpolator. So let's begin to do the practical of Hessian polygon in the Arc GIS. So at first you have to open the Arc GIS. Then after opening the Arc GIS, you have to download this folder Spatial Interpolation from the description, and you have to copy this folder in the GIS folder. Then after that you have to do the refresh, and after refreshing this folder, Spatial Interpolation will appear in this catalog. Then after this, at first we are going to create a file geodatabase, because we know from the beginning the first step in the GIS is to create a file geodatabase, because all the works done in this workspace will be saved in the file geodatabase. So at first, for creating a file geodatabase, at first you have to right click here, go to new, then choose the file geodatabase, then right click here, rename, write name as spatial interpolation, then enter. Then after this we have to make this file geodatabase as a default, and for making the default, right click here and choose make default geodatabase. Then after this you have to click here on the plus sign, then you can see the shape file for this tutorial 8, that is spatial interpolation. So for the Hessian polygon, at first we have to import the data Kathmandu watershed and rainfall station. So after importing the data in the workspace, at first we have to change the symbol of Kathmandu KTM watershed. So for that you have to left click on this symbol. This is green symbol, but you have to ensure that this is checked, not this. You have to check this, then this type of screen or this type of values will appear. Then after this you have to click here on this symbol box, left click, then you have to choose this option hollow, then okay. Then after doing this, then you have to search for the Hessian in the search box. So write Hessian, THIESSEN, Hessian, then enter. Then you can see the option for creating the Hessian polygon. So we have to click here, create Hessian polygon. Then this type of dialog box will appear. input feature, we have to drag the rainfall station. Yeah, and I have to write the name. I have to write the name as rainfall Hessian Kathmandu. Then after doing this, you have to click here environment, and from environment you have to click here processing extent, and from this you have to choose the same as layer KTM order sheet. Then after doing this, click on OK, then again OK. Then it will take a little time for processing. Then after processing, a Hessian polygon will appear. Then you can see the Hessian polygon is appearing here. You can simply label the rainfall station by right clicking on this and label feature. You can see the name of the rain gauge station. So after doing this, we have to clip this to the Kathmandu watershed. For that, we have to go to geoprocessing. So click on geoprocessing. We are going to clip this area to the Kathmandu watershed area. So for that, we have to go to geoprocessing. Then you have to choose the clip, and from clip in the input feature, we have to drag this rainfall. This is Kathmandu. Just we have created this. Then in the clip feature, we have to drag KTM watershed. Then after doing this, right here, rainfall Hessian Kathmandu, right clip. Then it will be easy for identifying. Then writing the name and following this procedure, you have to click on OK. Then it will take a little time for clipping. So uncheck this. Then you can see the Hessian polygon for the Kathmandu district, and in this figure we can see the each rain gauge, each polygon as a single rain gauge station. For example, this is for the Budanilkantha area. This is for Sundarijal. It means this rain gauge station covers the area for this area. So after doing this, we are going to see the attribute table. For that, go to open attribute table. Then you can see the object ID, input FIR, shape length, and the shape area. And for finding the individual area, it means like the area of Thankot, Naikap, Pani Pokri. For doing that, you have to click here and click on add field. Then after doing this, write the name, area. Then from here choose the short integer. Yeah, it is OK. Then OK. Then click here. Then right click. Then you have to choose this option, calculate geometry. And from this, you have to choose the square kilometer. Then OK. Then it will calculate the area for each station. It means like this. If you click here, then it show the area for this Kokana area, rain gauge influence area, and likewise others. So in this way, we have calculated the area for each rain gauge influence area. Then after doing this, we are going to calculate the Hessian weightage. And for doing this, you have to click, you have to go here, go to add field, then write Hessian, Thies, Hessian weightage. And from here you have to choose the float because this will be in decimal, then click on OK. Then after this, at first we are going to see the total area because to find the Hessian weightage, it is the fraction of individual area to the total area. So for finding the total area, you have to click here on the area. So at first clear the selection, then after clearing you have to click here, then right click, go to statistics, and from here you can see the uh, area, and then simply you have to select this, then copy this. For copying you have to select and then you have to press Ctrl plus C. Then after copying this, click here on the Hessian weightage, then right click, go to field calculator. From this we have to click here, we have to double click on this area, then divide by the total area, that is 650, then click on OK. Then in this way we can calculate the Hessian weightage for all the individual influence area. So this was all for the Hessian polygon. So in second number we are going to learn about triangulated irregular network, that is TIN. TIN is a simple way to construct a surface from a set of known points. It is a particularly useful technique for irregularly spaced points. The TIN approach is an exact interpolation method. So let's do it in Arc GIS for the triangulated irregular network. So for doing this, at first you have to uncheck this also. Then you have to import the Melamchi area. Simply zoom to layer Melamchi area, then Melamchi elevation point. So you have to make sure that the Melamchi area lies above the Melamchi elevation point. Then you have to double click here on the symbol of Melamchi area. Then you have to choose this option, the hollow, then OK. And for the TIN, you have to go to search, then write TIN, then enter. Then from this we can choose the option create TIN. Create TIN, then write the name Melamchi TIN. Then in the coordinate system we are going to use the PCS coordinate system always. So for doing this, click on project coordinate system, and from this you have to go to the UTM. From UTM you have to choose the WGS 1984, then northern hemisphere. Then from this northern hemisphere you have to choose the for 45, this is for WGS 1984 UTM zone 45, then click on OK. Then in the input features, you have to choose the Melamchi elevation point. And from the Melamchi elevation point, from this field, you have to choose the elevation, and from the tag you have to choose the elevation. Then you have to check this. Then go to environment. Then go to processing extent. Then from this value, you have to choose the value same as layer Melamchi, yeah, Melamchi area. Then click on OK. Then OK. Then after doing, it will take a little time for processing. Then after processing, it will show the Melamchi TIN area, and simply uncheck this option. Then right click here, go to properties, symbology, or go to class number of 5, classify, natural breaks, then OK. And then from yeah, let it be same for the color ramp, then apply, then OK. Simply zoom to layer. Then it will take a little time for showing. Then you can see this is the 3D image of elevation surface of Melamchi area. This brown color denotes the uh, elevation area that is that is most highest from others. Then in this way, this green color denotes this elevation, and this blue color denotes the lowest elevation. So in this way we have done for the triangulated irregular network. So in the third number, you are going to learn about inverse distance weighting, IDW. So IDW interpolation determines cell value using a linearly weighted combination of a set of sample points. It is the function of inverse distance. It means the inverse distance means the lowest distance will cover the large area, and the highest distance will cover the smallest area. So let's begin in Arc GIS for doing the IDW. So at first you have to uncheck this, then go to catalog. Then you have to drag then you don't have to drag anything. Simply you have to go to search, and in the search write IDW, then enter. Then you have to choose this IDW Spatial Analyst. Then after clicking here, in the input feature you have to drag the rainfall station, and in the Z value you have to select the maximum rainfall. Then you have to write the name, output name, write the name Kathmandu rainfall IWD, Kathmandu rainfall IDW, and then in the output cell size let it be 30 by 30. Then after doing this, click on environment. From environment you have to click processing extent, and from this you have to choose the same as KTM watershed, then OK, then OK. Then it will take a little time for the processing for IDW, inverse distance weighting. Then zoom to layer, and you can see the rainfall. This green denotes the maximum rainfall, and this type of color denotes the lower rainfall value. So for classifying to only the 5 classes, simply you have to right click here and go to properties, then go to symbology, and then classified, and then from this choose the class number 5, and then classify natural breaks, then OK. Choose the color this or this color, then apply, then OK. Then in this way we have done for IDW. So in this by performing the IDW, you can see the rainfall, you can see the maximum rainfall and the lowest rainfall area. For example, this blue color denotes the maximum rainfall area, and this red color denotes the minimum rainfall area. So in this way we have done for this IDW. So in the fourth number we are going to learn about Spline Tool. So Spline Tool is a deterministic interpolation method that estimates value using a mathematical function that minimizes overall surface curvature, resulting in a smooth surface that passes exactly through the input point. So let's begin in the Arc GIS for performing the Spline Tool. And for performing the Spline Tool, at first you have to uncheck this, then you have to go to search and write Spline, then enter, or enter, or let me. So in the previous, for the IDW and for the IDW, we can crop it to crop for the Kathmandu, and for cropping to the for clipping to the Kathmandu area only, you have to search the raster clip, then raster clip, then you have to choose this option, clip data management. From this you have to drag the Kathmandu rainfall IDW and the Kathmandu water sheet for clipping to the Kathmandu water sheet. Then you have to check this, then click on OK. Then it will clip to the Kathmandu district only for the IDW. Simply uncheck this, click here, go to properties, go to symbology, then classified, then from here choose the class 5, then classify, and it is OK. Natural breaks, then from here you can choose the color this, then apply, then OK. Then it will show the data for the Kathmandu district rainfall, and this sky blue color denotes the minimum rainfall area, and this pink color denotes the maximum rainfall area. So let's continue to the Spline Tool. And for the Spline Tool, at first uncheck this and search here Spline, then you have to choose this option Spline, spatial analyst, and then you have to drag the Melamchi elevation point to the input features. From this you have to choose the elevation and write the name Melamchi elevation point. Melamchi elevation point. Then cell size 30 by 30. Then go to environment. Then click here processing extend. From this you have to choose the same as layer Melamchi area. Then OK. Then OK. Then it will take a little time for the processing for the spline tool. We have done for the elevation point, so it will draw the elevation surface in 3D. Then it is created. So simply right click here, zoom to layer. Then right click here, go to properties. Choose this color. Then in the classes 5, classify natural breaks. Then OK. Then OK. Then in this way we have done for the spline tool for drawing the surface, and this blue color denotes the most highest elevation point, and the red color denotes the lowest point. So for clipping to the Melamchi area, then you have to go to search and write raster clip, then enter, then click here clip data management, then drag this Melamchi elevation point. Then in this below box we have to drag this Melamchi area. Then check this, then click here, then OK. Then it will clip to the Melamchi area only for the surface view. So after doing this, uncheck below data and right click here, go to properties, go to classified, and from here choose this color, or you can choose any appropriate color. Let it be this color. Apply, then OK. Simply or go to properties, change the color to this, apply, then OK. Then it will show only for the Melamchi area surface elevation drawing. So this red color denotes the minimum elevation point, and this blue color denotes the highest elevation point. So this was all for the spline tool. So in the 5th number we are going to learn about the kriging. So for kriging, go to Arc GIS, then search kriging, 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 then enter, then click here kriging spatial analyst. Then in the input feature Melamchi elevation point, and in the Z value you have to choose the elevation. Then in the cell size write 30, go to environment, then from the processing extent you have to choose as Melamchi area, then OK, and write the name, let it be this, then drop down this, it is all OK, then click on OK. Then it will draw for the kriging. tool. Simply uncheck this. Then it will take a little time for processing for the kriging. So after doing this, it has simply drawn for the kriging. So at first you have to change the number of classes to 5, or you can change you can change as per your requirement. So in this video I'm going to change the class now 5. Then go to classify, natural breaks, then OK. From this color choose any appropriate color, then apply, then OK. And then for clipping to the Milamchi area only, go to search and write raster clip, then enter, then clear, choose this, simply drag this, then Milamchi area, then click this, click also this, then OK. Then after doing this, it will clip to the Milamchi area only. So it will take a little time for processing. After done, it will show here. Yeah, this all. So simply uncheck this and right click here, go to properties, go to this symbology, classified, and from this choose the another color, then apply, then OK. Then it is for the kriging tool, and it denotes the, and it show the surface area for the kriging, and this yellow color denotes the lowest elevation point, and this blue color denotes the highest elevation point. So this was all for the kriging, and in the last we are going to learn about the kernel density. Kernel density tool calculates the density of features in a neighborhood around those features. So it can be calculated for both point and the line features. So let's begin. And for doing this, at first you have to go to the catalog, and from this you have to drag the data this for showing the number of hospital. So simply zoom to layer, then label features, then you can see it show the name of the hospitals, and by using this tool kernel density, we are going to show the density of this hospital in the surrounding area. So for doing that, go to search, so before going to search, you have to drag this data Kathmandu shape file. So click here to this option, the hollow, then OK, then go to search and write kernel density, then enter, then click here, and in the input point we are going to drag this data, the number of hospital, then write the name kernel or kernel Kathmandu Kathmandu hospital, then write the cell size as 30, then go to environment, then forcing extend and same as layer Kathmandu, then okay, then okay. Then after this simply zoom to layer, then we are going to clip for this one Kathmandu, and for clipping click here, go to search and write raster clip, then click here clip data management, then drag this data, then in the output extend drag the Kathmandu, then check this, check these two, then click on OK, then you clip to the Kathmandu district only. So you can uncheck this. So after this you can uncheck this and right click, or you can check this up to, or simply uncheck this, go to properties, then go to classified, choose the then go to classified natural breaks, yeah, it is okay, and then from this color ramp choose any appropriate color, let it be, then apply, then okay, then zoom to layer, then you can see the density of the number of hospitals, and this blue color denotes the most highest density of hospital, and this green color denotes the number of hospital from 0 to 1, and this blue color denotes the number of hospital from 8 to 12. So in this way we have learned about the kernel density. So in this tutorial just we have learned about the Hessian Polygon, TIN, IDW, spline, kriging, and the kernel density. So this is all the lesson. So thank you, and please subscribe to our channel. Thank you so much.